trigonometry, we need to learn 3 words. One of which you know already, which is called hypotenuse. So in any right angle triangle, there's 3 sides that have special names. The hypotenuse, opposite, and the adjacent. Let's define what they are. We already know what hypotenuse is. This is hypotenuse, right? The side opposite to the right angle. So write it down. This is hypotenuse. And the other word is called opposite. What is opposite? Opposite is the side opposite to the angle. So you write opposite. And the third side that's next to the angle is called the adjacent. Adjacent means next to, right? Adjacent. So instead of using the full word, I'm going to label adjacent as A, hypotenuse as H, and opposite as O. Yeah, capital will be better. Oh, it doesn't have to be. Doesn't have to be. All right, let's do the next question. Let's move on. Now let's look at the next question. We're going to label the hypotenuse. Opposite to the right angle is H. The side opposite to the angle is O. And the side next to the angle is called A, adjacent. Does that make sense? There's some extra practice. Can you try the one on the right side of this booklet? Label O, H, and A. This is important for this exercise. So make sure you know what a hypotenuse is, what an opposite is, what's an adjacent. Okay, I'll give you about a minute. We'll go through the answers. I want you to have a try. Okay, so in this triangle, this is H, opposite to the right angle. The one that touches the angle, see that angle touches the theta, is called A, adjacent, and the side opposite to the angle is called O. Does that make sense? Okay, next one. This is H, this is O, opposite to the angle. Yep. It's good for you if you write the whole word down. It helps you to learn the word. And this one is O. This is H. This is A. All right, any question? Have you got it all down? All right, we'll now go to part 2 of trigonometric ratios. We're going to do some investigation. Okay, let's continue. Part 2, trigonometric ratio investigation. On here, you will see there are 2 triangles. One big one, one small one. What you notice about them is that they have the same angle. Both are 30 degrees. Both have a right angle. And then what we do is we're going to measure the ratio of these sides. Let's do opposite over hypotenuse. So this is, let's label the side, that's opposite, that's hypotenuse, that's A. A, O, H, right? Oh yeah, there's something there. All right. Okay, now, let's do the first triangle. Let's do BC over AB. BC is 2 over 4, so write 2 over 4. And what's that equal to in 1 decimal place? 0.5. Right? 2 over 4. BC is 2. And AB is 4. So the 2 over 4 is 0.5. Next one. Let's do adjacent over hypotenuse. Adjacent is 3.5. Right? Over AB, which is 4. 0.875. Okay, let's write this down. Let me write it again. 3.5 over 4 equal to 0.875. Get the idea? Okay. 0.8. Okay. 0.88. Alright, good. Next one. What's the next one? BC over AC. What's BC? 2 over 3.5. What's that equal to? 0.57. 0.57. Thank you. Okay, so we did it with the small triangle. Can you repeat the same thing with the big triangle? Yes, they're similar. Okay, good. So let's go through this. Yeah, let's see why they are. Let's go through this to what's the next one? 4 over 8, you get 0.5. And what's the other one? 7 over 8, you get 0.88, correct to 2 decimal place. And you get 4 over 7, which is also 0.57. Okay, so you see that they are equal. And they are equal because they both have 30 degrees. They are both related to the angle 30. Therefore, they are all the same. Okay. Well, they would be the same if they have the same angle. Yep. They are approximately equal. Approximately equal. I rounded my answer. I forgot. Yep, there you go. Thank you. Alright, now what we do is, let's do some investigation. Sorry. Okay, thank you. Alright, next one. What do you notice about the values of the 3 ratios? Yeah, they have the same ratios for both triangles, right? Let's delve deeper into this. Let's work out what sine 30 is on your calculator. So on your calculator, press sine 30. Now make sure you have a D on the top, which stands for degree. Yeah, sine is this button, S-I-N, that you've seen since year 7 but never know what that means. Sine 30, it's actually a shorthand for sine, S-I-N-E. But when we read it, we still read it as sine, not sin, because it sounds bad if you say sin. It's sine. Sine 30 is 0.5. So write 0.5. You don't get it? You just type in sine 30.
What does that mean?
Well, we're going to know what that means soon. Let's work out what that cos 30. Well, I'm going to do that soon. Thank you. 0.87 and then tan 30 is 0.58. Okay, now you may wonder what they are. Why do we do sine 30, cos 30 and tan 30? You may guess that 30 must come from the angle 30, right? That's the way the 30 comes from. But why do I ask you to do tan, sine and cos 30? Because they are related to this number, right? It's related to opposite over hypotenuse. And the cos 30 is related to adjacent over hypotenuse. And finally, tan 30 is opposite over adjacent. They have the same value, isn't it? Well, close. They are very close. And they are not the same due to the fact that we rounded our answers. If we didn't round our answers, if the measurement is exact, they will be identical. Okay? Okay, let me draw it again. Let me try again. Alright, so basically we worked out sine 30 is related to opposite over hypotenuse. This is opposite adjacent over hypotenuse. This is adjacent over opposite over adjacent. Okay, so we noted that the ratio is the same for any triangle. that the opposite over hypotenuse is always the same no matter how big the triangle is, isn't it? So the opposite over hypotenuse is always 0.5 no matter the triangle has side length 2 or side length 4, as long as they are both 30 degrees. So we call this ratio the sine ratio. This allows us to find the unknown side length given one side length and an acute angle. Okay, for example, I'm going to work out what y is. And to work out what y is, we know sine 30 is opposite over hypotenuse, isn't it? Right? Now, we know what the opposite is, or we don't know what the opposite, but we do know what the hypotenuse is. So I could work out what opposite is. So it goes, what's sine 30 again? 0.5. And that equals to opposite, which is y, over hypotenuse. So now I could figure out what y is, because I know sine 30 is 0.5. So you go y equal to 14 times 0.5. The answer is 7 centimeters. So that's what trigonometry is about, using angles to work out missing sides. Or given the sides, work out the missing angles. Yes? Yeah, it could be 40. Then it will not be 0.5. It will be something else. Yeah, that's why we need a calculator. Does that make sense now? So each of these angles give you a ratio of these sides, which will in turn helps you to find the missing side. Does that make sense? Yeah, it's like a life hack. You can put it this way. All right, any question? Let's do more questions. One more page. Yep, 3 parts. It's like a 3-part documentary. All right. Let's move on. Sokotoa. Some of you learned this already, but let's go through this. Okay, watching. Now, let's label the side. This is hypotenuse. This is opposite. This is adjacent. Earlier, we discovered that sine theta is simply a ratio of 2 sides of a right angle triangle, which is opposite over hypotenuse. And cos is adjacent over hypotenuse, and tan is adjacent, opposite over adjacent. Now, how we're going to remember this is to remember the mnemonics Sokotoa. S-O-H, C-A-H, and T-O-A. In this order. Sokotoa. Remember, S-C-T. Get it? Get the idea? Sokotoa. Right? Sokotoa. All right, let's continue. Okay, let's do this. All right, this one, first label the opposite, hypotenuse adjacent first. And we know sine is opposite over hypotenuse. What do? We do 20 over 25. Does that make sense? Right? Now we have to simplify it. What's 20 over 25? Thank you. Now how about the next one, cos? So car is A over H. So what do? 15 over 25, which is 3 over 5. So it's like probability when we simplify the fraction. Okay, tan theta is opposite over adjacent. And this is 20 over 15, 4 over 3. Get the idea? Very easy. All right, we've got the next one. Next one's a little bit tricky. You need to pay attention to the triangle. Now, we're not finding angle. Watch this. Let's say the angle was y. Watch. This is y. That will be h. That will be o. That will be a. Get it? So sine is opposite over hypotenuse. So you have to write 15 over 17. Right? And then cos y is adjacent over hypotenuse. And tan y is, what's tan y? 15 over 8. Get it? Okay. Now what if the angle got changed? What if they do z instead? So in that case, this will be adjacent instead of opposite. This will be opposite, but that will still be h. Right? So therefore, to find sine z, you do opposite over hypotenuse, 8 over 17. Right? Let me write the fraction like this. 8 over 17. Next one, cos z is adjacent over hypotenuse, 15 over 17. And finally, tan z is opposite over adjacent, 8 over 15. Okay, got it? So you've got to pay attention which angle you're using. So this is what today's exercise is about. Getting familiar with the sine length h, opposite, adjacent, knowing the definition of sine, cos, and tan. Alright, so you can start the exercise now and finish it